What if politicians could command the weather? If they could create a powerful monsoon as an act of warfare, a whirling hurricane which flattens a city, or an endless drought which starves a nation? Terrifying, right? But what if we told you that this astonishing ability to manipulate the weather is not confined to the realms of fantasy?
Can these scientists fly into a cloud and make it give rain to a needy Earth when it would not naturally do so?
Weather manipulation techniques have a long history, dating back to the mid-20th century. In 1946, Vincent Schaefer, a chemist working for General Electric, conducted the first true cloud seeding experiment by aircraft.
The discovery that humans could really affect clouds was made by this American. Nearly 30 years ago, Vince Schaefer was in his laboratory making clouds. It was a hot day, so he grabbed some dry ice, frozen carbon dioxide, simply to help cool his freezer. But doing that transformed the cloud.
He dropped 6 pounds of crushed dry ice into a cloud in the Adirondack Mountains of New York. Almost immediately, snow began to fall.
There's a record of a pioneer experiment. First results were not spectacular, but they have definitely proved that rainmaking is a practical proposition, and it's one we shall hear more of in the future.
In later experiments, Schaefer and other GE colleagues would discover that certain types of particles are more effective at helping ice crystals form. Silver iodide, they found, is one of the best.
We have evidence now that hail and other severe storms can be modified. I think the time is rapidly approaching when we will be able to no longer depend on the vagaries of the weather, but perhaps can do something about it. It may be easier to control the weather than to forecast it.
Obviously, cloud seeding is a useful tool in the fight against drought. There are already instances where it has been put to good use in this context. Facing the daunting UN prediction of water scarcity for 14% of the world's population by 2025, the UAE proactively launched the UAE Research Program for Rains Enhancement Science in 1990. This initiative employs evolving technologies, including cloud seeding, to address the country's increasing water needs amidst its limited annual rainfall.
Some of these clouds, by nature, sometimes it rains, for example, only 40 to 50% of its rain that's processed in the cloud that comes as rainfall. So by these operations, we try to increase this amount by, for example, from 15 to 30%.
Over the years, the project's effectiveness is noteworthy. For instance, in 2022 alone, 311 cloud seeding missions resulted in nearly 1,000 flying hours. This consistent progress underscores the importance and benefits of artificial rain in water-scarce regions like the UAE. While cloud seeding technology holds immense potential, it is important to acknowledge the existing challenges and concerns associated with this implementation. Cloud seeding does not guarantee precise control over the resulting weather patterns, making it challenging to determine its long-term effects accurately. The use of silver iodide, for instance, raises questions about its impact on ecosystems and human health if released in large quantities. To address these concerns, scientists are actively researching alternative, non-hazardous materials for use in cloud seeding technology. Edward Graham, a meteorologist at the University of the Highlands and Islands, UK, explains that simpler methods like salt flares have already been employed in places like the UAE.
In terms of the effect on the environment, cloud seeding nowadays, at least in the UAE, just uses salt flares, and that's what you get in table salt on your kitchen table. So there's no actual harm to the environment. Traditionally, chemicals such as silver iodide, which mimics the crystal structure of ice, have been used, but they're not used in the UAE today. In terms of carbon footprint, the planes that fly up into the clouds are just small planes, and when compared to the billions of cars on the planet and the huge planes planes doing international air travel every day. It's just a drop in the ocean in terms of carbon footprint and carbon emissions.
Furthermore, cloud seeding's potential to disrupt natural precipitation patterns poses risks to neighboring regions and ecosystems. Altering rainfall distribution can have cascading effects on water availability, agricultural systems, and biodiversity. Disruptions in the natural water cycle may exacerbate water scarcity in certain areas, while causing excessive rainfall and flooding in others. However, what is typically seen as a challenge in one context can become an opportunity in another.
Back in July, the Chinese Communist Party marked its centenary with a ceremony attended by tens of thousands of people on Tiananmen Square. Now, a report has just been released by Beijing's Tsinghua University revealing that the government artificially changed the weather for that event.
This dichotomy was not lost on military strategists. The strategic potential of weather manipulation, a concept that may sound like science fiction, began to take form. A seminal venture into this uncharted territory was a collaboration between the US Department of Defense and General Electric. The endeavor, known as Project Popeye. Conducted during the Vietnam War, the project's goal was to flood enemy supply routes by modulating rainfall patterns. This bold paradigm shift in warfare tactics served as the cornerstone for subsequent developments in the militarization of weather manipulation.
In China, they're waging war on the weather, a drought so severe they're firing rockets into the sky to make it rain.
China has taken weather manipulation to new heights, surpassing other nations in its ambitious pursuit. Already capable of artificially manipulating the weather over its major cities, China's aspirations reach even further. By 2025, it aims to extend its reach to modify the weather over half of its vast territory, a prospect that has raised concerns among neighboring countries, particularly India. China's weather manipulation capabilities also hold significant potential as a military strategy. With military involvement and a vast workforce, China has developed aircraft and anti-aircraft guns to manipulate cloud formations and precipitation. By artificially altering rainy conditions in border regions, a nation can impede enemy troop movements and logistics operations, effectively slowing down adversary forces. This real-time tactical advantage can be invaluable in military conflicts. The ability to control the weather, even on a localized scale, provides a unique element of power projection and can shape the outcome of military engagements. By altering rainfall and monsoon cycles, China's activities may disrupt agricultural productivity in countries such as India, Myanmar, and Vietnam. This raises the specter of rain stealing and strains regional relationships, highlighting the geopolitical implications of weather manipulation as a tool of power. Addressing the challenges posed by weather manipulation requires international cooperation and effective regulatory frameworks. Collaborative efforts among governments, scientific communities, and international organizations are crucial to ensure responsible and accountable use of weather manipulation technologies. As we witness in China's mastery of weather manipulation techniques and its grandiose weather modification program, the gravity of its geostrategic implications becomes apparent. The ability to shape regional weather patterns and potentially utilize weather manipulation for military purposes presents a formidable tool of influence. Yet, as we stand at the precipice of this extraordinary power, we must confront a profound question. Is humankind truly ready to wield the awesome and dramatic power to control the weather?
As satellites take their place alongside computers as powerful scientific tools, the meteorology of the 1970s can deal quite well with large-scale weather systems that develop over a few days. But the weather machine operates on many different timescales, from thousands of years for making or melting great ice sheets to the fleeting lives of individual clouds.